Okay, well, welcome everyone to today's webinar of a low-cost submetering solution, the single circuit meter. And before we get started, I'm just going to review a few webinar logistics. Today's webinar is based on an evaluation by the National Renewable Energy Laboratory, and you can find the full report as well as summary documents on gsa.gov, and we'll also be posting links in the Zoom chat window so you can have direct access. Today's webinar offers continuing education credits, and to receive credit, complete the post-webinar survey, which we'll be sending out tomorrow. And if you don't receive a copy of the survey, please reach out to Michael Hobson. The webinar today should be in listen-only mode for all of you except for the panelists, but you can submit questions using the Q&A button on the bottom of your screen. And you don't need to wait until the end of the presentations to submit questions. In fact, we encourage you to submit questions well in advance of the Q&A session. Today's webinar is being recorded and we will share it. And you can find presentation slides and recordings for all of our Outbrief webinars at gsa.gov. And you can also access all webinar recordings on our YouTube channel, the Emerging Building Technologies YouTube channel. And we're posting links now into the chat for both the Outbrief page and the YouTube channel. And now I'd like to turn it over to Mike Lowell. He's the project manager for the single circuit submeter evaluation, and he'll be facilitating today's webinar. Welcome, Mike.
Next slide. Next slide, Andrea. Thank you. Here you can see the agenda. After I give you a quick intro, Kevin Powell, our director, will share an intro to our CEBT program. After that, we'll have Willie Bernal Heredia, who will give us the overview and share the results of our study of the Maison submetering technology. After that, we'll have an on-the-ground feedback from Tyler Cooper in Region 8, which is Denver, Colorado, which is where this technology was actually installed and tested. And then after that, actually, I will be sharing quickly a lay of the land, just a quick sharing of another report that we're going to do subsequent to all of these technologies that we've been testing. We're calling it the lay of the land, which will be an overview of the technologies we've tested. And after that, we'll have 20 minutes for a Q&A. Next slide, and I'll turn it over to Kevin.
There we are. Thank you. Sorry, another one of those Zoom challenges. You'd think I would be better at turning myself off of mute. Thank you. So next slide. So as background, the Department of Energy issued a wireless metering challenge in 2013. The intent of that challenge was to spur industry to develop a low-cost, high accuracy submeter. And the point of that challenge was to spur industry to develop something that could give facility managers the ability to know what building equipment is using electricity and how much and when in a way that would be cost effective. And GSA has been an active participant in supporting this challenge from the outset. And that's because we see 4 key use cases for that kind of data. The first is to build tenants for the actual cost of what we call overtime utilities. That is to say, equipment that is running above and beyond the base building hours or load. And in particular, to be able to accurately bill for data centers and server rooms based on their actual consumption, not on their estimated consumption. And the second use case that we see as just critical is fault detection. And there's a growing array of software. We have a very advanced smart building software called GSA Link. There's numerous other sorts of dashboards, including from these vendors of submetering, that really what they do is they simply let you know what equipment is on that shouldn't be on, and what equipment is using electricity at a level that it shouldn't be using. And although that may sound simple, that's actually the core to extraordinary gains in potential efficiency, building efficiency. And the third use case is that we can identify opportunities for improvements. For example, at one of our submetering test beds, we monitored a server room. And what we identified in that server room was that it was in fact using a ridiculous amount of energy, way above what we were estimating and really way above what it should have been. What that submetering let us do is say, why is that happening? We were able to quickly identify some of the causes. They were really low cost, no cost measures to fix things. And then we actually drove down that energy consumption to something closer to what it should have been. And then the fourth use case is to identify the ongoing performance of those kinds of measures. So using that same server room as an example, we could both document that the changes have been made, that the efficiencies have been gained, but then we could also see and ensure that the operator didn't let things drift as they often do. So anyway, we're really excited to share the results of this evaluation. Miezon submeter was in fact the first successful winner of that DOE challenge. But before we dive into this, just a quick poll. So Andrea, could you launch that poll? What we really want to do is to understand what you all out there see as the greatest opportunity within those four categories. And I don't know, can we help?
They're coming in quickly. We're at about 208 of 307. When it starts to slow down, kind of like the popcorn kernels stop popping, we'll end the poll and share the results.
Okay. Perhaps we should move to the next slide, though. Oh, there it is. It's interesting. And that, yeah, that would not have been even what that would not have been what I would have thought. But I think it's super useful to understand that identifying ECMs, in fact, is the largest opportunity that folks see. But it's great also to see that distribution. So I think that what that shows is that there, again, we're not, you always wonder, are you on target? You know, you start a project, you think you know what these values are, but then ultimately when the rubber meets the road is when you do it. All right, well, let's move on. Oh, just a quick note, did everybody else was not able to see that? Well, anyway, okay, moving on. Sorry.
So Kevin, are you seeing the screen? We've moved on to the next slide.
Yeah, no, I'm assuming that this means that we're kicking it over there to Willie.
We are, thank you. And Willie, you're on mute.
Great, great, thanks. So I'm a research engineer. I was a PI for the measurement and verification efforts at Cesar Chavez building for this technology, and I'll be diving a little bit deeper into that. We can go to the next slide, please. Great, so let me start discussing, I guess, some background on this. So traditional approaches to submetering used to come in two flavors. So we had the advanced metering infrastructure. This was highly accurate meters. However, they were designed to be installed for the whole building or very large end uses. And it did have limitations in terms of access to granular data. Also, this type of meter, as I said, is for very small, or like very specific purposes, but it can get very expensive due to the meter and also because of the installation. And the other flavor that we found here is I guess, customized solutions for circuit level submetering. So they had the great thing is that they can achieve what you were looking after, which is submetering, like even for the small loads. However, they don't scale easily because you require a custom approach to them, so it can get very costly on a per point basis. They also lack the reliability that you would expect for this type of meters. So this is kind of what we found originally. Can we go to the next slide? Now I want to describe what the type of new approaches that we've seen in submetering and analytics. Because just to remind yourself, like submetering will only get you get you so far in terms of getting an idea of what's going on, but it won't really provide energy savings by itself. So it's important to add that word, analytics. And let me describe 3 different approaches that we've seen and how we categorize them. So what we've seen is, you see on the left side, we have the full panel meters. So this category, the NREL technology would fit in here. These are meters that can monitor up to 42 circuits in a panel, and they use a voltage tab along with CTs. And CTs is a current transformer. This is a way for us to make sure we can get readings for amperage. The other type of meter that we've seen, the other type of category that we've seen is the wireless CTs. These are, and the Centrica meters actually fit into this. These are CTs that are wireless. They don't have any wires connected to them, so they can be easily installed in panels. However, because they don't have a voltage tab, we don't have accurate readings of voltage. We don't have very good, can capture the interaction between current and voltage in a circuit. So that's why the accuracy might not be the highest for them. And these tend to be best for FTT. And the third category that we've seen is the single circuit meter. These tend to be higher accuracy CTs. However, they tend to have a larger footprint. So they might not be the best if you want to install all the loads in a panel, for example. But they will require a voltage tab, CTs, and the best application for them probably would be large pieces of equipment or a whole to monitor the mains of a panel. I just want to remind everybody that we've had a series of webinars on this. We have extensive reports with the finance for each of these technologies that you see on the screen right now. We can go to the next slide, please. But now let me dive deeper into this specific measurement verification effort. We were studying the Miazon technology, and we deployed this technology at the Cesar Chavez Memorial Building in downtown Denver. This is a 10-story building. It's all electrical. And it's a multi-tenant building, so sometimes we would find that multiple agencies would share on the same floor and even the same panel. We can go to the next slide, please. Yes, so let me talk a little bit about the architecture for the technology, how this actually works. We have, what you see on the screen, you're going to have the 3, maybe 4 components actually here. On the left side, you'll find what is the physical equipment that is connected to the circuit. Here we have the CTs as well as the meter. So those 2 are providing the measurements, and those are relaying wirelessly that information to the gateway, which is the green graphic over there. Eventually, the gateway does some long-term storage as well, and it's going to relay that information to the cloud. And that is for long-term storage as well as visualization and analytics. And on the right side, we have a smart device so you can access that information as well as make sure you can use some of the cloud-based platform to come up with some results for that and visualization as well. So this is kind of the architecture, the end-to-end process of what's happening for you to get that information. The Meason technology does not use proprietary current transformers. It uses a voltage tap and, as I said, the cloud-based analytics as well. Finally, the only thing I wanted to point out maybe is that a single gateway can connect information from multiple meters. And I think that's a great way of making sure there's some cost savings in there. I think we can go to the next slide, please. Great. So let me talk a little bit about the plan, the measurement verification plan for that. So we wanted to make sure we were comparing apples to apples, so the closest that we can do. So this comparison was a side-by-side comparison. And that image that you have over there, it shows two chiller disconnects. You have chiller 1 and chiller 2. And I want to point out that we installed the meters in the same circuits so that we were getting the same type of information. And we were using the same period as well as the same time intervals. So we're trying to make sure everything was the same. But something to point out here is, I want to show you in this picture is the white boxes that you see over there, that says data logger, the meter, the reference systems, and the antenna. That is all part of our reference meter. And the two small red boxes, that's the Meason meter and the bridge. And the bridge is the same as the gateway, by the way. This is just the piece of equipment that relays data to the cloud. But you can see the difference in terms of size, and it can probably give you an idea in terms of installation time. But this is kind of our side-to-side comparison configuration that you see over there. And what we use for this is we use revenue grade metering for this project. We wanted to make sure we had the most accurate data available. I think we can go to the next slide, please. Great. So let me start showing some of the results that we got. Here you have two pictures of two different loads, as you can see, with very different dynamics. This is for a day in September, and what I'm showing is power consumption throughout the day. The 1 minute data has been aggregated to 15 minutes, and the reason why we're doing that is because this is the most important piece of information usually for this type of metering. But you can see that in the mains there's a lot less variability than in the fan power VAB box. And that is something that is very good results, because we can see that the Meason meters can perform accurately even for different type of dynamics. So in terms of the VAB, we see high fluctuation, we see high cycling. However, the meter can accurately track the power consumption there. As well, also we see that when we have low power on the VAB, the Meason meter is actually tracking closely to our reference revenue grade meter. And forgot to mention, the red line is going to be the Meason technology, and the cyan is going to be our reference meters. We can go to the next slide, please. So a different type of load that we found here was the chillers, and I'll describe why that difference occurred. We saw some different results in terms of the chillers. And what we have here is 1 week worth of data aggregated to 15-minute intervals for chiller 1 and chiller 2. As you can see here, this is a high power load. So we're talking about around 100 kilowatts. And what we see is that whenever the chiller is running, whenever we make this cutoff at 2.5 kilowatts, whenever it's running, it highly tracks what our reference meters were collecting. However, whenever the chiller was idling, we saw some discrepancies. And kind of we noted that when we discussed that with Meason, and I think we can go to the next slide to explain that. So what the difference was between the chillers and the previous loads that I showed was the type of electrical configuration. So we have two different types. For example, the main panel was a standard Y configuration, while the chillers use a delta configuration. This is just the way the the load is electrically connected to the power supply. What we have here is the delta configuration tends to be used for large equipment with big inertia, in this case chillers and large motors, and the reason is because it can produce a high inrush current, so it can have a very high starting current, and that's the reason why they use. And what we saw is that for wide configuration loads, we didn't see any problems even at low power levels. We saw that the Meson technology tracked really well. For the delta configuration, as I show you in the graph, that was a slightly different case. We didn't see that, we saw that at low power levels, and there was some discrepancy there. The vendor has stated that they developed new meters that can improve the accuracy for that type of load. NREL has not validated those meters, but it's good to. I think that would be something that we can that if somebody's interested, would be able to follow up with the vendor on that. It's also important to use high accuracy CTs that can also mitigate those measurement errors as well. I just want to point that out. I think we can go to the next slide. That I'll be summarizing what the results were for this. So I think a great takeaway is the title in this slide. We found high accuracy for this technology, except whenever the chillers were idling. And as I mentioned before, it's because the delta configuration we found to be culprit here. But I just want to show you here the slide that even once we pass that threshold, even the chillers perform really well at below 2% for the total energy error. So I think that's a great takeaway here. We found that the technology can definitely produce type of results. It's reliable, and these results can be replicated as well. We can go to the next slide, please. Great. I want to talk a little bit about installation now. An electrician performed the installation within a day. We installed this equipment in 6 different loads, and it took the electrician 6 hours for 3 gateways that were connected to 18 current transformers and 6 meters distributed in 2 panels and 2 HVAC disconnects, by the way. What you see on the right side is a picture, it's a close-up of the meters. So this box over here was pre-configured by the distributor, and the reason we did that is because it saved a lot of time in installation. So this was not something that setup was already, it was shipped to us like that. That's definitely saved us some time because an electrician didn't have to do that. So it was a much easier way of installing this, a simpler way, as well that it allows us to install this outside the electrical panel as well. So that way, if the sensors need to be reset or something needs to be changed, that can be done without powering down the panel. So I think that's a great way of installing this type of meters. But you see over there is going to be 2 Meson meters on the right, and then 2 disconnect breakers on the left. So as you can see, even the footprint for this type of sensor is really small. A couple of things that I just wanted to point out. Well, the installation didn't pose any problems or concerns. We do require a certified electrician. And I think that's all I have for this slide. I think we can go to the next one. Oh, something I forgot to point out. Yeah, I definitely gave 6 hours for installation of time on that. And I want you to consider as well the time that it took for us to install our reference meters, that it was about 3 times more than that, just because of the complexity of the system. Great. Now, let me talk about cybersecurity concerns and the clearance process for this. For this pilot, we did not connect to the internal system here at GSA. So we actually installed a standalone network for this metering system. And it had its own dedicated cellular modem to transmit anonymized data to the cloud. However, connectivity to any other GSA system, whether that's a building automation system or the GSA Link platform, we would need to go through the full GSA IT security review and approval process. So that's something that for this pilot project we did not perform for that due to, I guess, time constraints and make sure that was not the scope of this project. Yes, and I think this is something that GSA is taking a look at and coordinated with its security department to determine the cyber clearance process required for broader deployments. As I said, this was for a single building in this case. We can go to the next slide, please. Great. Something I want to point out is that these meters had provided high resolution and high accuracy data. We did not embark on the mission of identifying or detecting faults or identifying ECMs as part of the scope. However, because of the resolution and high accuracy, it is clear that we can use those to support FTD and ECM tasks in this case. Another thing that would be important to point out is for facilities without a BAS, the accurate high resolution data could support FTDs and ECMs. And in the case with facilities that has an existing BAS, as the Cesar Chavez has, that actually has GSA Link, they can be used to monitor systems not typically monitored, such as lighting and plug loads. We can go to the next slide, please. Part of this, the Miazon services as well, it includes cloud-based analytics. So they do have analytics engine running in the cloud-based platform. And this is, through that, you can actually, you can use role-based alarms and benchmarking as well as FTD algorithms for the building. However, we noted that, however, we did not evaluated those services. However, those are available. Those are available at a cost. It does have subscription costs that can range from 12 to 48 per meter, depending on the features. However, for our pilot project, we did not use those services, and so for that, there's no ongoing cost to integrate data into GSA Link or other analytics platforms outside the ones at Miazon. So for that, we didn't have any subscription cost, just gathering the data and making sure we could upload it later to a different analytic platform. We can go to the next slide, please. But however, what we did do was get a better idea of the effort required to do a GSA Link integration. GSA Link uses the SkySpark platform, and that's what we did at NREL. We wanted to make sure, we wanted to demonstrate the feasibility of that type of integration. And what we did is make sure we created the infrastructure required to actually collect data from the Miazon server, download it, and eventually upload it into our SkySpark platform using standalone Python scripts that can communicate through the API. And this was a proof of concept, so that can actually be done for the GSA Link. It didn't require much effort, and the APIs are well documented, so that was great. That's why we can actually do it in very limited time. We can go to the next slide, please. Yeah, let me talk a little bit about the cost per meter load. So we show here two types of prices. We have the per point cost for the testbed and per point cost for a volume with a volume discount. And the difference is, as you would imagine, is the testbed, it was a small pilot project, so we were looking at six loads. So what we saw is that the cost would be around 900 on a per point basis. However, if more meters and equipment is purchased, then we can that drives the price down to around $400 on a per point basis. And this includes everything going from the electrical installation, the pre-configuration, as well as equipment costs. And just to remind you that just for the data, making sure we can get the data that doesn't require subscription costs. So that's something to take into account. We can go to the next slide, please. Great. Let's talk about the lessons learned that throughout this deployment. So for us, it was very important to have line of sight to ensure reliable communications between the wireless meters and the gateway. And let me remind you, on that architecture diagram that I showed before, there's a lot of wireless communication in here. And I think that's what makes it a lot easier to set up, and the installation time is a lot lower, but that makes sure that we got to make sure we have good connectivity nonetheless. So a couple of lessons here is, another is the one gateway per electrical room is recommended to avoid interference, because having two might actually like fight each other sometimes. So I think that's something that like only one would actually make more sense. Also, the pre-configuration of the meters definitely help us reduce installation time, and it simplifies future efforts for troubleshooting as well. If we're using a single CT on a three-phase equipment, it will be very important that the load is well balanced. If we have a load that is not balanced, then our recommendation is to use 3 CTs for that as well. We can go to the next slide, please. Great. I have best practices now. So a couple of takeaways here. It's very important to size the cities appropriately. So going by the rated breaker values, I think that would add uncertainty and decrease accuracy for this. So our recommendation would be to use an amp meter to spot check current at full load. So that would be the best way to do it. Also, it's important to avoid undersizing because it might lead to inaccuracy readings, and it would be clipping the readings at a certain point. The other thing is, I think for this type of installations, we need to have a clear monitor objectives before we install the submetering. Once we identify what the end use case is, whether it's FTD or whether it is a tenant billing where we actually might need high accuracy, I think that will give a better idea of what type of equipment we require. If we want to go for high accuracy applications, then installing high accuracy CTs for error sensitive applications would be the best route, especially as the incremental cost of those is only approximately 10% more. We can go to the next slide. Great. A couple of the deployment recommendations. Oh, thanks. Great. That is good. So yeah, a couple of things. What the best use cases we've seen for this? I think these are high accuracy CTs. They can be used for tenant billing. Also, we can use them to monitor the entire panel of the mains or the individual loads. This would not be the best if you want to monitor 42 circuits in a single panel. Would not recommend that. I think it would take too much space. So we find that the most value is for overtime utilities or devices that have high power consumption in the case of chillers or pumps. And finally, and this would be a great addition to existing data analytics infrastructure as a GSA, because it would be able, one, to monitor loads that are not part of that, or in the case of systems without GSA link, it would be able to add FTD and ECM capabilities. And now I would like to, I think this is a slide that I have, the last slide that I have, I would like to introduce Tyler Cooper, the Supervisory Energy PM for GSA.
Thanks, Willie. We'll go next slide. So just kind of going to go over some of the on-the-ground feedback we've had after having installed these in the field. In terms of installation maintenance, one of the, as Willie mentioned, one of the most important factors with these submeters is doing pre-planning, doing a complete electrical panel audit inventory in your building, then identifying what specific circuits or panels you want to monitor. It's going to give you the most accurate results, making sure that you're getting the most bang for your buck when you're going through and installing these, and have the right circuits identified. As Willie mentioned, having the meters installed in a separate panel Gives you more freedom in that electrical room, makes maintenance on any of these easier if there are communication issues. And then along that same line, if there are any data disruptions, you know that there's a maintenance issue that needs to be able to be checked on site. So in that sense, the only real issues you're going to have with these would be if there's a loss of communication, but compared to existing tech, which would be similar to existing technologies. So within that, you have a lot more opportunity to get this at a low-cost solution compared to normal full-scale metering efforts. Next slide. So one of the primary use cases we identified, as Kevin mentioned earlier, was accurate billing for tenant equipment. Data centers is obviously something where we want to be able to directly pass through utilities to tenants. We found one example here that's mentioned was courthouse in Salt Lake City, where the original estimates that had been negotiated with the customer ended up being half of the measured utility use on this space. Another example in terms of tenant pass-through of utilities, but we typically haven't been able to bill for before, would be situations where you have multiple tenants on the same floor of building, same space. Having that opportunity to go down to that panel level or circuit level allows you to break out utilities between different tenants, and we'll get more accurate billing in those situations. Next slide. So secondary use cases, I think one of the things that we've identified regionally that as a need that hasn't been brought up, hasn't necessarily been easiest means previously, was monitoring energy usage from central plant equipment. This is one of the things we've identified as need through our guiding principles programs, as well as just general energy allocation principle in general, especially in campus settings, where we've got central chiller plants, central boiler plants, particularly that, being able to monitor the energy usage to those chillers, and then also installing BTU meters downstream allows us to accurately go through and say, hey, allocate the usage to each of the buildings, and making sure that we've got the proper EUIs for those, which is critical when you're going through that guiding principle certification. Other use cases, as Kevin mentioned, that we're targeting ESPCs, M&V activities. If we install these ahead of time, we can identify equipment parameters, how those are operating, and then it allows you to get a more accurate baseline usage with those without having to rely on BAS data. And then moving forward, you know how those ECMs are performing with accurate readouts from the piece of equipment with the sub-metering efforts. Next slide. So in conjunction with that, kind of what we've identified as a need within that is how to house this, integrating it into our regional SkySpark server. Just gives us more freedom to go through and run those analytics off of that. So this is kind of a long-term goal that we're working on, to be able to go through and analyze this meter data without having been tied to a third-party software provider, and integrating that in without integrating that in on a regional basis. That's kind of where the benefit of that is, because it's single circuit data, it is more granular, and we aren't relying on our full building level meters at the switchgear level. Next slide. I believe that's passed back to Willie at that point. Oh, one more slide for me. So deployment hurdles, as we mentioned earlier, the biggest piece with this is GSA IT security clearance. As with anything, if it's going on our network, it has to go through and get passed, and then getting that automatic porting of data over to the GSA Link server is kind of the next step that we'd be looking at. With that, I'll pass it back to Willie.
Great, thanks, Tyler. So something I wanted to point out here is the submeter and analytics types. So here you have the four that I described briefly in introduction. We have here on the left is the NREL meter. It's a full panel. We also have the panoramic power or the centric emitters here. as well as the MIASON, that's the third one here, and the advanced metering infrastructure that we have on the right side. We can go to the next slide. The next slide is a table that summarizes the best use cases and some additional information that was cost, accuracy, and as well as I guess certain characteristics of those meters. As I said, we split it in these groups. We have 4 groups. We have 2 different manufacturers that might fit into the same bucket. That's the voltage, the ABCTs by Centrica, and the single circuit meter by MIASON. So we are working on this, what we call the lay of the land report on submetering. That is going to include recommendations, best use cases, and some details on how to get the best benefits out of those out of that technology. We are working on this. I won't go into much detail, but this is something that is currently happening, and we'll be sharing that once we can we complete that report. And I think that's don't have anything on that. I think we can jump into Q&A. So
I had to mute myself. So let's see. I'll start off with the grayed out questions. Or are the grayed out questions, Andre, are those ones that have been answered?
Yes, so we don't need to answer those. We'll start with the yellow,
Okay.
yellow highlight, and we have a lot of questions. We won't get through all of these. We'll try to respond to as many as we can, and we'll also be sending out some follow-up answers following the webinar.
Okay, first question. Manshika asked, is there a plot with actual air versus time or other independent variables? In our analysis so far, we have found the reactive power, and as a result, power factor ends up impacting device accuracy. Did reactive power have an impact on your analysis? I'll turn this over to Willie, but I will tell you that we've also had issues with power factor. I'll let Willie talk in more detail.
Yeah, that's a great question. We've seen that this type of meters, they are not, we cannot categorize them as revenue grade, but we've definitely get very good readings for power, current, and power factor. That definitely has not been the case for all the meters we've evaluated. I think there's further information on that in the technical reports, but what we found is, at least for the MIASON meters, that those readings were in the same order of magnitude as the results that we provided here. I know here we're mainly talking about power, but we saw that for the other quantities, it tracks really well as well. And let me also mention something that sometimes the pilot projects are, I guess, limited in scope. We haven't tested all the loads that could be out there. Specifically, we haven't tested, at least for these meters, we haven't tested BFT's applications, so that might add a lot of noise into the sensor, and that might diminish accuracy. We haven't tested the fullest extent of that because at least that building, we couldn't find a large enough load that we were interested in looking at with that specific configuration with a BFT. But as I said, at least for all the loads that we tested out there, we found very good results, as you can we showed today.
Thanks, Willie. Next question is, what was it specifically that made the installation of these meters easier or faster to install? Is it anything beyond the box build, quote unquote?
Yes, I can take that one. I actually started answering that one on the chat, but what I want to say is definitely is the streamlined process of there's minimal configuration done by the installer or the user. Like once you connect them, they're going to pair each other. They're going to pair up. So the gateway is automatically going to find the meters, and it's going to start collecting that information. There's no programming required at all. All that is streamlined process. I think is a great benefit for this. And I guess the reduced number of components, in this case, we are only talking about CTs, meters, and gateways. There's nothing else more involved for that.
Yeah, thanks. Next question. What happens when the internet is unavailable? Does it continue to record locally on the gateway? And the answer is yes. Both the gateway and the meter have storage capabilities internally to themselves. So that data is stored and can be recovered. Next question. David asked, what is the rough dimension? Oh, sorry, that's already been answered. What calibration schedule is recommended for the meters and et cetera?
I'm a little bit confused with calibration. There's no calibration done for these meters. We installed them and we used information that they were collecting. And that's how we evaluate it. And we didn't have a calibration period. I don't know if that was the intent of the question. We didn't have to calibrate, and they just work just from the manufacturer. Or maybe you understood better that question than I did. I don't know. I think that's what I have.
And it just goes back to right sizing your CTs too. So as long as your CTs, your current transformers are sized correctly, that will take care of the calibration that you're concerned about. Well,
yes. The thing is that all these accuracy, the accuracy claims by or statements by the manufacturer are based on full range. So if I have a 10 amp load and I'm using a 100 amp CTs, then it's going to be harder for you to get the accuracy that you want. So that's the real reason why we always recommend using spot checks to understand what's the real power consumption of that load and try to match it as closely as possible.
Okay, thanks. Next, it's mentioned that these submeters monitor lighting and plug loads. Can these also monitor receptacle loads, including automatic receptacle controls per ASHRAE 90.1?
Sorry, Mike, can you say that again?
Sure. It's mentioned that these submeters monitor lighting and plug loads. Can these also monitor receptacle loads? And then they say including automatic receptacle controls per ASHRAE. And Willie, of course, we also have Liaison on who could help you answer this if you're not quite sure.
Well, I wanted to point, I was just going to point out that we did not, for this evaluation, we didn't use plug loads. As we mentioned, one of the best use cases would be for larger loads. If you want accuracy at that level, then maybe a different type of meter might be appropriate. So this, we were metering chillers, VAV boxes, and anything. All the loads that we were looking at were at least 2 kilowatts, for example. So that was something good to keep in mind. For this, because they give good accuracy readings, good high accurate readings for this type of loads. But if we're looking at 100 watts, I think that would be harder to do. But I don't know. Maybe Mason wants to add something there.
Okay, thank you. Next question: how does this technology differ from smart breakers and smart breaker panels?
What I understand about, well, I guess my understanding about smart breakers would be that they can actually disconnect quickly in terms if there's a fault condition or currents exceed certain threshold. I don't know the technology involved in the type of metering there, to be honest with you. Those would be very fast devices that can actually track that type of load. And I guess those would be more for like preventive ways or disconnecting if there's any fault detected in the system. So I don't think this would be for that. I think the highest accuracy that you can get for this would be like the most granular data you can get is 1 minute. As I say, I'm not very familiar with them, but usually smart meters are used for that. The smart breakers are used to trip the system in this case of a fault. So that would be very high, very fast readings.
Thank you. Sometimes other devices such as flow meters, temp sensors are required for ECMs and M&V, or M&V for ECMs. Can the same gateway transmit such data from these other devices? And then for high voltage, 480 volt, can the CTs be installed hot without a shutdown?
Oh.
So first question, Willie,
Yeah.
so can the same gateway transmit such data such as temp sensors and flow meters, et cetera?
That would be probably a question for Miazont. At least the meters that we use, no, I would say no. They have been used for electrical purposes. They might have other meters that actually do that. In terms of the gateway, I'm not 100% sure of that. We were looking at on the electrical side of things. And on the second question, that was, sorry, what was the second question?
High voltages like 480 volt, can CTs be installed hot without a shutdown?
Yes, I want to make 2 points here. So the first one is we actually tested loads of this type of meters, and the whole integrated approach can be used for 120, 240, 208, 480 voltage loads. Now, the CTs, they can't, but I think that's more in terms of requirements by the building owner or the site. For this demonstration, we did not power down the loads. The CTs were installed hot.
Okay, thanks. Do these submeters capture harmonics? Also, can these perform trending analysis and produce reports?
They do. This is something that, as I mentioned, this is a subscriptions service that Miazon provides. They can actually do the type of analytics and provide a report with recommendations on how best to improve the system. Yes. We, as I said, we did not evaluate those services to our limited scope, but that's something that they can provide. They provide as a service with an additional subscription cost.
Okay. And let's see. I'm trying to pick up the next question here. What do you think about installing the submeters on the circuit breakers like some developers do?
The circuit legs?
I'm not quite sure what that means.
Yeah, I don't.
Maybe just a clarification. So these are in the circuit. They're clip-on CTs. They go right on the wires feeding the breaker. Is that correct? Is my assumption there correct, Willie? Right?
Yes, correct. So if you picture the breaker, we are going to have the cable, the circuit come into there, and we would actually clamp it right there. So once you take out the dead front of the electrical panel, those will actually clip onto that.
Okay.
So you do need to remove the dead front of the panel, but after that you can just hook them up. Yep. Okay.
Are there any residential applications for these devices, or are they really just aimed at commercial buildings?
A second meter like 120 loads, I think they could be used for that. As I said, my main concern would we would only look at this on the commercial side. That was really the purpose of this demonstration. So I would say that might be a question for me as a follow-up, and it would also be highly important to know the size of that load. Like, I think that would be important to know whether those are compatible with that.
When a CT is not in line of sight with the gateway, can it be wired to the gateway, I assume? Yeah.
Yes, the CT is sorry, just to make make sure this is clear. So the CTs are wired. They need to be connected to the meter by cabling.
Right.
I mentioned, maybe hopefully not to get confused with the other type of meters that we evaluated. Some of them were wireless CTs. There was no cable, but for this presentation, everything that we've showed today here about the Meason technology, they do have wires and they have to be connected to the meter.
Okay. Next question is, how do the gateways communicate to the internet? And how reliable was their communication depending on their installed location?
Yeah, I think that's a great question. A couple of things here. So we, as I mentioned, we have a wire CT with a meter. That meter is wireless. That meter is communicating wirelessly to our gateway. And that gateway, it acts as a cell modem. It's a cell modem that communicates to the internet. So there's two wireless communications. So if any of these links kind of gets interrupted, we might see some, we won't see loss of data because the meter, the gateway, and of course the cloud have a certain amount of memory, so they can actually store information. And the meter is going to store some of it. The gateway is going to they can actually store information, a much larger amount of information for months, for example. And finally, we have long-term memory, long-term storage in the cloud. But if any of these links might get interrupted, we might see some loss of. We won't see loss of data because they are stored at individual components here, but they will resume once a good connection is present. What I mean, a good connection that is highly relevant in type of the place where we are. And I think this is highly dependent on the type of network provider that we can use. So it's really good to check whether which provider for a cell modem connection would be the better for that particular site. So sometimes it's going to be good to use one, sometimes it's going to be another one. So what we usually do is go to the electrical or the closet room and actually have different providers on our cell phones and see which one has a better reliability or better connection for that. So it's really a matter of having one, as I said, a good provider for that specific site. And the other thing would be that I mentioned during the presentation is to make sure we have clear line of sight between the meter and the gateway, so we have good connection, and we don't have multiple gateways inside a small rooms, because then we might deal with some interference because of that.
Thanks, Willie. Well, I apologize to those who submitted questions whose questions were not covered, but we've run out of time. With that, I think I'm going to turn it over to Andrea. And Andrea, can you just quickly share where things will be posted, et cetera?
Yes, we'll be sending out a follow-up email, and that will include some follow-up answers to some of the Q&A, as well as links to the recording and to the slides. Before you receive that, the slides will be posted to the gsa.gov and on our YouTube channel. And for AII credit, you'll be getting a survey tomorrow with 5 questions. By completing that survey, you can request credit. And so thanks for all the panelists for your presentations, and for all of you who've attended, and for your great questions. And we look forward to seeing you on the next webinar. Thanks, bye.